You open Claude, you click this drop-down, and there's a list of models staring at you. So, which Claude model should you use? Most people pick the smartest sounding one and hope. That's the wrong move. And I'll show you why. Because the thing that decides your results isn't the model, it's the workflow. Have you ever noticed that two people can use exactly the same AI, yet one produces professional quality work while the other gets mediocre results? The difference usually isn't the AI, it's the workflow. Many beginners open Claude, type a single prompt like, build me a website, and expect perfect results. When the output isn't exactly what they wanted, they blame the AI. But experienced users rarely work that way. Instead, they treat AI like a team of specialists. One model helps plan the project, another builds it, another reviews it. Sometimes they even ask a completely different AI to challenge the results before calling the work finished. That's exactly what this workflow is teaching. Now, before we begin, one important disclaimer. This isn't the only correct way to use Claude. It's one practical workflow designed to balance reasoning quality, speed, and cost. Depending on your project, subscription, and budget, you may choose different models or combine them differently. With that in mind, let's break down every step and understand why this workflow works so well. Understanding the big picture. Before looking at the individual steps, notice something interesting about this diagram. It isn't organized by AI models. It's organized by phases of work. There are 3 phases: think, build, judge. That's an important distinction. Most beginners immediately jump into the build phase. Professionals spend far more time thinking before they build anything. It's similar to constructing a skyscraper. No construction company starts pouring concrete on the first day. Architects create blueprints, engineers review them. The client approves them. Only then does construction begin. AI projects benefit from exactly the same approach. Why Claude has multiple models? A common beginner question is, if one model is smarter than another, why not just use the smartest one for everything? Imagine you're running a movie studio. You have a director, camera operators, video editors, and production assistants. Technically, the director could perform every job, but that would be a terrible use of everyone's time. Instead, each person focuses on what they do best. Claude models work in a similar way. Some are optimized for deep reasoning, some for everyday work, some for speed and efficiency. Choosing the right model for the right task often leads to better productivity and, depending on how you use Claude, can also reduce usage or costs. The first phase is planning. Ironically, it's also the phase that many beginners skip. Let's see why it's so important. Step 1. Plan. Using a high-capability reasoning model. The workflow recommends starting your project with one of Claude's strongest reasoning models. Why? Because planning is fundamentally different from building. Imagine you ask Claude, build me a customer support chatbot. That sounds straightforward. But Claude immediately has dozens of unanswered questions. Who are the customers? What products does the company sell? Should the chatbot search documents? Should it use a knowledge base? Should it connect to Salesforce? Does it need multilingual support? Should conversations be stored? Without this information, the model has to make assumptions, and assumptions often lead to revisions later. Instead, experienced users begin with planning. A much better prompt would be, before building anything, ask me one question at a time until you completely understand the project. Then, create a detailed implementation plan. Don't write any code until I approve the plan. Notice what's happening? You're no longer asking Claude to guess. You're asking it to become your consultant. Those few minutes spent planning can prevent hours of rewriting later. Step 2. Review the plan before building. Planning isn't a one-way command. It's a conversation. Claude proposes an approach. You read it. Maybe you remove unnecessary features. Maybe you simplify the project. Maybe you realize something important is missing. This is much easier to fix on paper than after hundreds of lines of code have already been generated. Think about building a house. Changing a blueprint takes minutes. Changing a completed foundation could cost thousands of dollars. The same principle applies to AI-generated work. Once you're happy with the plan, approve it. Only then move on. Step 3. Use the most advanced reasoning. Only when it adds value. Sometimes your project requires exceptionally difficult reasoning. For example, designing a complex software architecture, breaking down a large research project, solving difficult engineering problems, or analyzing many competing requirements. In situations like these, using Claude's most capable reasoning models can be worthwhile. However, not every task needs that level of reasoning. If you're drafting documentation, creating marketing copy, or implementing a well-defined feature, a more efficient model may be perfectly capable. The key idea is simple. Reserve your highest capability reasoning for problems that genuinely benefit from it. Don't use a race car to drive across a parking lot. Once the thinking is finished, it's time to execute the plan. This is where most of the work happens. Step 4. Use the right model to execute the approved plan. Once your requirements are clear, the implementation model doesn't need to invent the project anymore. Its job is to execute. This might include writing code, creating documentation, designing HTML pages, building APIs, drafting reports, or generating content. Many users choose Claude Sonnet for this stage because it provides an excellent balance between capability, speed, and efficiency for everyday professional work. The important point isn't that one model always performs every task best. It's that planning and execution are different activities. Once the difficult decisions have already been made, implementation becomes much more straightforward. Step 5. Offload repetitive work to faster models. Now imagine your project contains hundreds of repetitive tasks. Maybe you need to summarize hundreds of documents, rename thousands of files, generate metadata, rewrite product descriptions, extract information from invoices, translate large batches of text. These jobs usually don't require advanced reasoning. They're repetitive. For these kinds of tasks, many users choose faster, lighter models because they're optimized for speed and efficiency. The idea is simple. Save your most capable reasoning models for decisions. Use lightweight models for repetitive execution whenever the task doesn't require deep reasoning. Step 6. Make Claude review its own work. One of the most powerful techniques in AI prompting is self-review. Instead of asking, "Is everything finished?" ask something more specific. Compare your output against the original requirements. List every requirement you failed to satisfy. Explain why, fix the issues, and then present the corrected version. This changes Claude's role. Instead of being the creator, it becomes the reviewer. That simple shift often catches missing requirements, logical inconsistencies, formatting mistakes, incomplete implementations, and overlooked edge cases before you ever see the final result. It's like asking a student to proofread an exam before handing it to the teacher. Even after self-review, the work isn't necessarily complete. Now comes quality assurance. Step 7. Ask for a second opinion. One important lesson in AI is that every model has strengths and limitations. That's why many experienced users ask for an independent review. Instead of asking, "Does this look good?" try asking, "Review this as if you're trying to find flaws. What assumptions did we make? What requirements are missing? What risks should we consider?" A reviewer who actively searches for weaknesses often produces far more useful feedback than one simply confirming the work. Fresh eyes frequently catch things the original creator overlooked. Step 8. Let another AI review it. The workflow then recommends something many professionals already do. Ask a completely different AI to review the work. Different AI systems are trained differently, have different strengths, and sometimes notice different types of mistakes. For example, you might create a project in Claude, then ask another AI to review it for security, clarity, factual accuracy, or missing edge cases. The goal isn't to prove one AI is better than another. It's to benefit from different perspectives. This is similar to having two experienced colleagues independently review the same document before it's published. Step 9. Save what you learn. The final step may be the most valuable of all. Whenever you discover a recurring mistake, don't just fix it. Document it. Maybe you always forget accessibility. Maybe your documentation lacks examples. Maybe your code doesn't include enough comments. Maybe you repeatedly forget mobile responsiveness. Write those lessons into your reusable instructions, project guidelines, or files like CLAUDE.md if that's part of your workflow. Over time, your AI instructions become more refined. You spend less time repeating yourself and more time producing consistent, high-quality results. That's how experienced users gradually improve not just individual projects, but their entire workflow. Let's see how this looks in a real project. Suppose you're creating an online course. First, use a high-capability reasoning model to design the curriculum and learning objectives. Next, review and approve the course outline. Then use an implementation-focused model to write each lesson according to that approved plan. If you have repetitive tasks, such as generating lesson summaries, timestamps, quizzes, or CEO metadata, delegate those to a faster model. Afterward, ask Claude to compare the finished course against the original curriculum and identify anything missing. Finally, ask another AI to review the course for factual accuracy, clarity, beginner friendliness, or overlooked issues. Each model contributes where it adds the most value. Before we finish, let's quickly cover a few common mistakes. The first is skipping the planning stage and jumping straight into implementation. The second is expecting a single prompt to produce a perfect result without any iteration. The third is using the most capable model for every task, even when a faster or lighter model would be sufficient. And the fourth is publishing AI-generated work without reviewing or verifying it. Avoiding these mistakes alone can dramatically improve the quality of your results. So, what have we learned? This workflow isn't about chasing the newest or most expensive AI model. It's about matching the right model to the right job. Think carefully before you build. Review your plan before committing. Choose models based on the work they need to do. Verify the output instead of trusting the first draft. Seek independent reviews when quality matters. And keep refining your reusable instructions so every future project starts from a stronger foundation. The better your workflow, the more consistent your AI results will become. If you found this breakdown helpful, you'll love what's coming next on Frontier Tech. If that sounds interesting, consider subscribing so you don't miss future videos. Thanks for watching, and I'll see you in the next one.